Dear students, in this class we will discuss consumer preferences in the case of perfect complements, a situation directly opposite to a case of perfect substitutes. In the case of perfect substitutes, indifference curves are linear. Now, in the case of perfect complements, examples of perfect complements are shoes and shoelaces, or a right shoe, left shoe, such examples. So, in the case of perfect complements, the indifference curves are L-shaped, right angled. The shape is like this: commodity X, commodity Y. Indifference curves showing different levels of utility are L-shaped. These indifference curves represents a case in which goods go together. Goods go together. And in the case of perfect complements, utility functions are represented by what is known as non-differentiable utility functions. In the case of perfect complements, utility functions are non-differentiable. And this shape of the indifference curve shows that the pairs of goods X and Y are used in fixed proportions. X and Y are used in fixed proportions represented by the vertices of the curves. That is, the vertices of the curves. Goods are used in fixed proportions represented by the vertices of the indifference curves. As an example, you consider a consumer who prefers 1 ounce of cream with 8 ounces of coffee. 1 ounce of cream, 8 ounces of coffee, and preferring 2 ounces of cream with 16 ounces of coffee. 16 ounces of coffee. Only by increasing cream and coffee in fixed proportions, his utility will increase. If he continues to get 1 cream and 16 ounces of coffee, you will not change. Utility will not change. Only by choosing the goods together, utility will increase. Now, these concepts can be formalized by specifying the mathematical functional form of the utility function uxy is equal to minimum of alpha x beta y. Minimum of alpha x beta y, where alpha and beta are positive parameters. Minimum means, MIN means, utility is given by smaller of the terms in the parenthesis. If alpha x is the smallest term, then utility is equal to alpha x. If beta y is the smallest term, then utility is equal to beta y. So the utility function is given as minimum of alpha x beta y. Now in this figure, 1 by alpha units of x and 1 by beta units of x, y give a utility equal to 1. 1 by alpha unit of x and 1 by beta unit of y will give the consumer a utility equal to 1. And suppose that x increases to 2 by alpha. X alone increases to 2 by alpha. Then utility will remain at 1. For utility to increase from 1 to 2, the requirement is that x increases by 2 by alpha and y increases by 2 by beta. Then only utility will increase. Utility will increase. If the quantity of x alone increases, utility will not increase. If the quantity of y alone increases, utility will increase. For utility to increase, both x and y should increase together. Now, here as x alone increases, utility will not increase, so that marginal utility of x is equal to 0. That means, in the case of perfect complements, the non-satiation assumption is violated. As marginal utility of x or marginal utility of y can be 0, the assumption non-satiation axiom is violated. Because for utility to increase, both x and y should increase proportionately. And there is no substitution possibilities. Also, MRS is undefined at alpha x is equal to beta y. MRS xy is undefined at alpha x is equal to beta y. So, as MRS is undefined at alpha x is equal to beta y, and as indifference curve has a kink where alpha x is equal to beta y, and as consumption takes place only at the kink, the vertex, we will say that the slope is also undefined. The slope is also undefined. So, slope is undefined, non-satiation axiom is undefined. This is because even though the curve is continuous, it is not smooth. So, you cannot resort to calculus to assess the properties of indifference curves. To assess the properties, you have to construct tables. As an example, suppose that u is given as minimum of x by 2, y by 2. To construct various combinations of x and y, which will give u equal to 1. U equal to 1. Now, consider this case, x, y, x is equal to 2, y is equal to 2. Sorry, y by 3. Y is equal to 3. So that 2 by 2, 1, 3 by 3, 1. Suppose 2 and 4, 2 by 2, 4 by 3, utility is minimum of whichever ratio is small, again u is 1. And 2 by 5, again 1, or 3 and 3, 3 by 2, 3 by 3, 1. So you can find out, or you can characterize the utility function using different combinations of x and y by constructing a table like this, because you cannot differentiate it to characterize the indifference curve. So this is the case of perfect complements. Now another case we consider is barred commodities. We consider is the case of barred. The case of barred commodities. A barred commodity is one which the consumer does not prefer. For example, cigarettes. Now suppose that we have a situation in which one commodity is a good commodity, the other one is a bad commodity. Suppose that the good commodity is food, the bad commodity is cigarettes. The good commodity is food, the bad commodity is cigarette. Now, in this case, for the consumer to consume additional units of cigarettes and to maintain the same level of utility, he must be given more food, or he must be compensated with more food. So, what will be the shape of the indifference curves? The indifference curve will have this shape. The shape of the indifference curves are positively sloped with the u1, u2, u3, etc. and the utility increases as you move towards down and right. So u1 less than u2 less than u3, like this. Because if you compare this, a given food with a less amount of cigarettes. So this is the case of what is known as one commodity is a bad, the other commodity is a good. And bad commodities violates the non-satiation axiom. More is not preferred to less, actually less is preferred to more. Now a utility function for one commodity which is a good commodity, the other one is a bad commodity, is specified as uxy is equal to x into y raised to minus 2. Uxy is equal to x into y raised to minus 2. Now, MRSXY is equal to, can be written as MUX by MUY is equal to dou U by dou X by dou U by dou Y is equal to MUX is equal to, this can be written as dou U by dou X, that is y raised to minus 2 divided by minus 2 xy raised to minus 3. This can be written as equal to minus of y by 2x, and this is less than 0. So MRSXY is negative. That means indifference curve is positively sloped. MRSXY negative means MRS is the negative of the slope. So MRS negative means slope is positive. So this is the utility function if y is a bad, x is a good. Now this is a shape of indifference curve. It can be concave also. Such possibilities are there. The point is, if one commodity is a good commodity, the other one is a bad commodity, indifference curve is positively sloped. Whether it is straight line or concave, is a different issue.